Next, data centers. As I mentioned earlier, whereas learning and training is really about trillions of operations per second, billions and trillions of operations per second, inferencing is about billions of people, and in the future, tens of billions of devices connected to the cloud that needs to inference through the cloud. The amount of AI traffic, the amount of queries, artificial intelligence queries that will be presented to the internet will be absolutely enormous. We have worked last couple of 2-3 years with internet companies and software companies all over the world to develop the fundamental network. Now it's time for all of us to deploy it, to put it into the data centers and make those services available to everyone around the world. Almost every single mobile cloud service will be infused with artificial intelligence. The amount of traffic that we're going to enjoy in the cloud for inferencing is going to be really, really high. Today, the only way to do the inferencing is with CPUs. Today, the only way to do inferencing is with CPUs. And it's unfortunately too slow and it's too inefficient. There are ways to improve that. And so today we're announcing that we have introduced 2 brand new Pascal GPUs designed and optimized for inferencing. The Tesla P40 and the Tesla P4. The P4 is really cute. You should see this. You know, when people think about NVIDIA GPUs, they think it's very, very powerful. And in fact, it is. So this is a Tesla P40. Okay? This is the P40. And this little thing here, like a candy bar, is a P4. This will fit into any server. This will fit into any server. This will fit into a 1U OCP server, which means that any hyperscale data center in the world can connect an accelerator into that server and put this into a hyperscale data center. And any data center in the world, whether it's a company or a cloud service provider, can put this more powerful GPU in their data center. Okay? So 2 GPUs optimized for deep learning inferencing for the very first time. Brand new architecture and new instructions and new numerical formats designed for deep learning. So Tesla P4 and Tesla P40. The cutest graphics cards NVIDIA has ever made. Now, as I've said before, we're a computing platform company. A computing platform company is different than a GPU company. And the difference is software. The reason why NVIDIA GPUs has been used all over the world for deep learning is not just because the processor was optimally designed and ideal for deep learning, but because the entire software stack, from CUDA and CUDA DNN and all of our software packages on top, are ideal for very, very efficient processing of deep learning networks. Today, we're announcing something very new. Just as we have a very comprehensive software stack for training, we now want to offer a very comprehensive stack for inferencing, so that every data center can train their network on NVIDIA's deep learning computing platform and inference or deploy on NVIDIA's deep learning platform. One architecture, completely seamless, incredibly easy. Press one button and you're good to go. That software stack is called TensorRT. TensorRT is essentially a real-time optimizing compiler. And it takes and looks across the entire network and looks for ways to reduce its complexity. Prepare it for runtime, like an optimizing compiler, as well as optimizing across all of the layers. It could do vertical as well as horizontal. Vertical is through the depths. horizontal is within one deep, within one layer of the network, to do optimizations through fusing. Some mathematic functions and operations can be fused together to reduce the amount of memory traffic or to reduce the amount of computational load. We also do all kinds of auto-tuning capabilities so that this network can be as fast and as energy efficient as possible. Not only is the Pascal GPU P40 and P4 already a huge leap up from CPUs, about 40 times the energy efficiency, 40 times the energy efficiency and 40 times the performance above the state-of-the-art CPUs. Now with TensorRT, we can even reduce the complexity of that network even further to get another boost. We see somewhere between 2 to 3 to 4 times the speed up running TensorRT. Can you imagine by adding one accelerator, you can speed up artificial intelligence production by 40, 50, 60 times with just one accelerator? The amount of cost savings for the data center and the amount of throughput enhancement is really quite shocking. So, Tesla P4 and P40 and TensorRT represents NVIDIA's new inferencing production pipeline. Let me now demonstrate it to you. What I'm going to demonstrate to you is this. So this is 90 video streams. These 90 video streams are coming in at 720p. First of all, it doesn't matter what format it comes in. And the reason for that is because of the internet, you can't control the format. And this could be people who are taking videos, like many of you are right now. It could be people uploading videos. And what we want to do is this. You know that one of the most important new applications for the internet is live video. Live video means it is not going to be recorded. Live video means if you don't enjoy it, it's over. Live video means if your son or daughter is having a karate tournament or they're getting a black belt and you're still traveling at work like me, and I want to enjoy that day, if somehow my social service did not let me know, it is over. Live video means if you don't pay attention, it will be over. And so the question is, how do we do this for several billion people? Everybody is loading video in China right now. Everybody is streaming video in the United States. I don't know how popular it is here, but all over the world, we're seeing live video streaming. And so the question is, how does the social network know which video would I be interested in and which video would I not be interested in? And who of my friends should I send a notification to let them know your child and my child are playing soccer right now? You might want to see this. How do we do that? Well, the answer, of course, is artificial intelligence. If we had a data center that had artificial intelligence and we knew what video we were watching, if the data center knew and could recognize what video we are watching, and once it can infer what the video is doing, it could notify the appropriate person who would be interested. Then we can watch the live video and enjoy that very special moment, and it would not pass by. And so this is 90 videos. This is being streamed into a Tesla P40. And the first thing that we have to do is we have to decode it. We have to decode the image. The next thing that we have to do is we have to image process the image. And the reason for that is because the deep learning networks needs the formats and the data to be appropriate. In the case of certain types of videos and certain types of images, it might have to be augmented and translated into 3D, in fact, for better image recognition. And so the next thing is image processing. It could be 2D image processing, it could be 3D image processing. And then after that, you need to do inferencing. Okay, inferencing. Using the network that was already trained to infer what is happening. So let's do that. Let's run this video. Let's run all of these videos through the server. Okay, so now all these videos are being streamed into our server. Imagine 1 billion people doing this right now. Guys? Ladies and gentlemen, this demonstration is completely live. So anything can happen. Anything can happen, and it just did. Okay, so these videos are now being decoded. Some amazing videos, actually. This is one of my favorites right here. I just realized that if I just had that board when I was a kid, I could play by myself. Look at that. It's perfect. And so incredible videos, really fun. Suppose I wanted to, can you do this? Can you just label all of them? It's inferencing. Could I just detect all of them and tell me what they are? Okay, so this guy's doing push-ups. That's right. He's playing a sitar. That's not bad. A sitar. Still rings. Sumo wrestling. Not bad. Swing. Table tennis. Tai chi. Tennis. Throw discus. Trampoline jumping. Not bad. Okay? Ladies and gentlemen, imagine billions and billions of videos are coming into the internet and we want to infer all of them. Maybe we want to detect which one of the videos are inappropriate for children. Maybe we want to detect which one of them are inappropriate for society at all. Okay? And so we could use the AI to understand the video, because there's just no way for humans to look at all of the videos on the internet. Now, suppose I just want to see, can you just show me, how about just sports, Olympic sports? And so I could, on the internet, say, just show me everything that's sports. So the future of video search, powered by artificial intelligence, is the reason why all of the internet companies are so dedicated to it. This fundamental ability is going to power the future of the internet, so that we could do searches. We can understand the content that's available on the internet. We could filter it according to our desire. Show me playing instruments, musical instruments. Really amazing. And it does it completely in real time. Okay? And so right now, if you think about what's happening, the first layer of artificial intelligence is sensing, just detecting. I recognize this is a person. I recognize this is a sitar. I recognize that's a flute. Just recognizing. Now, of course, don't forget, the computer has to figure out where to focus. Okay? It's called attention. You and I, very quickly, we can see that the piano in the background is not the most important thing of that video. However, the attention is really about the person playing the flute, a musician playing a flute. The neural net needs to have attention, the neural net needs to detect, and then lastly, the neural net needs to reason what is happening. This area of reasoning is a source of a great deal of research, and we have a lot of things to do to figure out what is happening in these videos, detecting circumstances, understanding semantics, understanding the meaning, not just the images. Okay? Now, we could also use neural nets. Thank you. Thank you. Good job, guys. Thank you. Let's go back to the slides. We could also train the neural net to do almost anything. And one of the things that we thought we would train the neural net to do for you is to do something that you and I cannot imagine. Just now, I can imagine doing this. It would just take a lot of time. But now I want to show you something that is not likely that you can do. For some people you can do, I cannot do. Suppose I were to learn the style of Picasso. Suppose I were to learn the style of Chinese pencil art. And if you showed me one of these videos I will redraw it. Not filter it, redraw it in the style of Picasso. To redraw it in the style of Picasso. Now, we can train neural nets, apparently, to do almost anything. And so, in this particular case, this neural net has been trained to learn the style of the artists, and then from the images, completely redraw the images in their style. Okay, so ladies and gentlemen, this is a technology that is from a partner of ours called Risto, and let's go ahead and run it, guys. This is currently going through one GPU. It takes one complete P40 to do this in real time. Of course, this is video from Taiwan. Really beautiful. This video is being decoded on a GPU. This is amazing, right? You guys recognize all this? So let's go ahead and turn on some artistic flair, shall we? So now the neural net is taking the video input and in real time redrawing. This is not filtering. This is redrawing. Do you guys understand? Okay? Not filtering, redrawing. You cannot filter it. This is not a filtering technique. It's a redrawing technique. And so the styles are fantastic. Did you guys see Picasso? I turned around. Somebody teach it Picasso. Let's leave it on Picasso for a little while. This is what Picasso would look like in a video. And so the network was trained with real Picasso paintings. How about Chinese pencil art? It's not a filter, it's a redrawing, resynthesized of every single pixel. Everything is resynthesized from the style that it learned in the different arts. Mosaic. And so the question now is, what else can we do? What else can we do? For example, we can now teach our network the styles of Picasso, and we can say, draw me a new Picasso. Draw me a new Picasso that is a landscape. Maybe draw me a new Picasso that's Taipei 101. Okay? Really, really beautiful stuff. All right, guys, thank you very much. So using GPUs for inferencing. This is going to be deployed into data centers all over the world. As I mentioned, the ecosystem around the NVIDIA platform is growing really, really fast. Almost every internet service provider that I know of, every consumer internet company has been using NVIDIA GPUs to train their networks. I mean, we're talking about the big companies, the small companies, the Googles, the Microsofts, the Facebooks, the Baidus, the Alibabas, the Tencents, the Yelps, the Twitters. Almost everybody is now adopting deep learning and AI to enhance their mobile internet service, to enhance their consumer internet services. The next step is, what about all the startup companies that are all over the world that are starting to understand the power of this technology, but they don't have the power of a data center behind them. They don't have supercomputers available to them. And so cloud service providers have now started to incorporate NVIDIA's GPUs into cloud services all over the world. We have a partnership with Alibaba to put the NVIDIA deep learning platform on AliYuan. The IBM Cloud has NVIDIA's deep learning platform. Microsoft Azure has NVIDIA's deep learning platform, and Amazon Web Services has NVIDIA's deep learning platforms. And this is just the beginning. And this is just the beginning. And I've only shown you all the ones that we recognize. But don't forget, cloud service providers are big and small, and they're all over the world. Startup companies now know exactly where to find NVIDIA's deep learning platform, and they could start their company, develop their network, and deploy it. We also have partnerships with enterprise computer companies. And the reason for that, of course, is large enterprises still need local prem computing. Too much of their data is too risky, too sensitive to put off-site. Whether you're a healthcare, a hospital, a research center, or maybe you would like to keep your retail data to yourself, or you're operating a fleet of cars all over the world. You can't afford to have that in a data center somewhere. You want to operate that yourself. Those deep learning computing platforms will be delivered to our customers through our partnerships with enterprises. Cisco, Dell, Hewlett-Packard, IBM, and Lenovo are all fantastic partners of ours. I really appreciate their support. They're now scaling out their servers for the enterprise. And here in Taiwan, because we know that all of these companies rely on this island to build the servers themselves. Here in Taiwan, we have great partnerships with Foxconn, and Inventec, and Quanta, and Supermicro, and Wistron. These companies are the world-leading companies in building servers. And with their partnership, we're now building GPU servers for training, for inferencing, for all of these companies out in the world that are starting to deploy deep learning into their production services. Today, I want to highlight one particular company. We have great partnerships with all of the server companies, but one particular company has been doing incredible work, and I really appreciate their partnership. Quanta has been working with us on GPU servers since the very beginning. Long before everybody realized the importance of GPU servers, Quanta has been a great partner of ours. They work together with us across the board, and I'm just showing you 3 versions of their servers. We partnered together to engineer the GPU server for training called DGX-1, the first of its kind, the first NVLink server, 8 GPU server, the first of its kind, the most powerful AI computer the world's ever seen. We worked together on Facebook's Big Sur. This is the Facebook server. It is also open sourced. And we also worked together on Hyperscale 1U OCP servers that includes the Tesla GPUs. This just represents 3 of their servers. They have 1U, 2U, 3U, 4U. They have 1 GPU, 2 GPU, 4 GPU, 8 GPUs, and every permutations in between. So it doesn't matter what kind of data center you would like to build. Our partnership with Quanta and QCT will make them available for you. I just want to acknowledge all of the hard work that their engineers have done, and I want to thank them for their support and partnership. Well, you've seen hyperscale companies, enterprise computer companies, cloud service providers, and Taiwan's GPU server makers all jumping onto GPU deep learning and jumping onto the NVIDIA platform. But the excitement is really out there yet with the startups. We have a program called Inception, and we work with startup companies all over the world. We now count over 1,500 AI startup companies that are using GPUs. 1,500. And they're being introduced every single day. They're using it for deep learning for cybersecurity. Deep learning has the ability to detect the most minor of intrusions before it becomes a serious problem, because it can recognize patterns of anomalies. Patterns of anomalies in the human genome is the beginning of cancer. Deep learning with genomics. If we can read the human genome and detect mutations early enough, we also have the technology finally to edit the human genome to prevent that disease to continue to spread. I believe that AI is going to cause a revolution in healthcare, and we're just so incredibly excited about that. Deep learning and self-driving cars. Drive AI is one of the companies we're working with 80 companies around the world in self-driving cars, simply because it's such an important, such a large industry. And you saw earlier a product from Artisto. This is a product from Prisma, using deep learning for art. Now, deep learning for art is a general way of saying deep learning for digital design. In the future, deep learning would be used to expand into all areas of design, to help you with a field called generative design. So when you're doing mechanical designs, in the future, it could actually finish the project for you. The first part of the project requires a great deal of inspiration and creativity, but the last part of the project requires a great deal of mundane work. That part AI can complete for you. Here in Taiwan, there's some fantastic startups as well. V5 for traffic analysis, just detecting traffic patterns, noticing the world, all the cars and traffic around Taipei. Discovery, using deep learning for e-commerce. So you take a picture of a thing that you like, and with their cloud service, it could find for you places that you can purchase that thing. Deep learning for safer cities. This is a really exciting area. Let me tell you why in just a second. And deep learning for retail. Notice with cameras and artificial intelligence, you can figure out whether you actually placed your products in the right place based on the traffic. You could see which one of your products is the most popular. If we had the energy to sit and look at our store and everybody come and go and what products they picked up, we would have better insight into how best to architect our retail stores. Imagine doing this for every single store. Using artificial intelligence is a wonderful way to do it. Skyrec. Great companies here in Taiwan. We need to continue to foster the startup community here in Taiwan. And AI is just a brand new discontinuity. It's a brand new beginning. This is the time to jump in.